What is up, everybody? Welcome back to the third installment of the Natural Language Processing for Tensorflow tutorial series. I'm Nate. Today we're going to use the input data that we made inside the first video and the model that we made in the second video to learn how to train our network. But before we do that, somebody asked a question in the comments. Hisham says, "Hey Nate, great video. I have a suggestion. Tell the audience what the big picture of the project is and what's our end goal." Great question, and I probably should have mentioned this earlier. But the main idea behind Word2vec is that each word is represented by a dense vector, right? So you can do things like king equals queen minus woman plus man. That's the famous one from the paper. But that's cool. So maybe we can try something like that with reviews. Or the other cool thing is that it performs extremely well on classification. So with reviews, we have 5-star reviews, we have 1-star reviews. We can tell what the rating is, and then we can make some sort of classifier where we feed it the positive reviews and give it a label that, hey, this is positive, I like these shoes. Or we could feed it a negative label, this product is terrible, and be able to draw a line in between them. So that's a really cool thing about Word2vec. Something else we could try could be doc2vec, which aims to make vector representations of the documents as well as the words. And these will be the same size as our words, so we can add and subtract them just like we do up here, just like we did with the king, man, woman, queen thing. So maybe we'll be able to say something like hat equals helmet minus the sports document plus the clothing document. And I think this is a pretty cool idea, so I think we should maybe try that with the reviews data. So back to the task at hand. We now have our input data and we have our network. So what we're going to do now is feed our data into the network with batches. So basically what that means is we're going to split our input data into smaller batches to feed in the network iteratively until we get through all of our input data. So the first thing that we're going to need to do is to split our data set. So if we remember, our X's are going to be our pivot words and our Y's are going to be our target words. So we have to split these into a training and a testing set. So we're going to do that using the train test split method from scikit-learn. So to do this, we're going to say xtrain, xtest, ytrain, ytest equals train test split, and then pass it our list. So that would be pivot words and target words. And this will do the train test split all on its own. What it's also going to do is it's going to shuffle our data. So it's not going to go in the same order that we gave it to, which is good. So the next thing we're going to need to do is set a few variables. So first we're going to set our batch size. We're going to let that be 32. And then we're going to do number of epochs. And we'll say 5. And the next thing we need to do is calculate how many batches that we have inside of our training set. So we're going to say num batches equals the length of our training set. And then we're going to do the double equals because this will round down to the nearest integer. So we're going to do double division divided by batch size. And that'll give us the number of batches in our training set. So num batches in train set. So now that we have that, we're also going to add one more variable here so we can save our weights after we're done training. So you're going to spend all this time training your network, so you don't want to have to do that over again. So we're going to make a saver. So to do this, we say saver equals tf.train.saver. And that's all we have to do there. Create saver to save our weights. And now what we're going to do is we're going to say for e in range num epochs. So for all the epochs that we have. And we're going to loop through all the batches in our training set. So we're going to say for I in range num batches. And what we want to do is we're going to slide through it with our batch size. So 32, 32, 32, 32. And when it gets to the end, because we allow for a variable batch size, whatever is left at the end, we're just going to feed that in whatever size it ends up being. So to do this, we're going to say for if I does not equal range num batches. So if it doesn't equal the last batch, we're going to say x batch equals xtrain, and we're going to say I times batch size. So that'll give us where we should be currently in the in our sliding window, and we're going to go from there to I times batch size plus batch size. So that'll give us the actual batch right there. And we're going to do the same thing for Y batch. Oh, these equal signs are going to bother me now. All right, so Y train, and then we're going to just copy paste this. It's the same thing. And in order to get those last ones that don't equal 32 batch size, we're going to say X batch equals X train. Oop. I times batch size, and then just a colon, and we'll close that. And we're going to do the same thing for Y batch again, just like we did above. So now we have the data and we can actually run our network. So to do this, we're going to put underscore and then L equals sesh.run. And here we put optimizer, loss, comma, and then we put our feed dict. So we just made our batches. So what we're going to do is we're going to pass in those batches to our feed dict into our placeholders. So our X batch is our X's, our Y batches are Y's, and those will go right here. And remember, that's none, comma, so that basically means a variable batch size, and it's just scalar integers that we're passing into our network. So feed dict equals, open up a dictionary and say X batch, Y batch, close that up, close our parentheses, and now we're just going to add a little statement to say if the step that we're on is able to be divided by 1000, let's print out our loss. Yeah, not that number. There we go. And we're just going to say print step I, and then of, so we'll say, why don't we say our number of batches too, and then what our loss is at that current step, and that's our L, which we got from here. So after that, let's go, let's say that for every epoch, let's also save our weight. So to do this, we're going to write save path equals saver dot save, and then write sesh, comma, and here you're going to put a directory that you're going to save your weights to. So I like to follow what a lot of people do, and that's just you write logdir, and this will create the directory if it doesn't exist, so don't worry about that. So logdir, and then name what you want your checkpoint file to be called. So we're going to say, why don't we say Word2vec underscore model.ckpt, and close that, and we should be good. So I'm going to run this real quick and see if this works. Just a quick reminder, I do have this data constraint still on up here, and we will turn this off when we go to train the full thing. And as we can see here, it has started, oh, and it's decreasing, so that's a good sign. Remember that because I do have that data constraint on, it's only going to be 4,500 steps per epoch, and that's really small. There's definitely going to be some problems there, and obviously we want to train it on a lot more data. So when we do go train on a lot more data, it'll be much more accurate, much better, but for now we just want to see that it works, and we can see that it does work indeed. So what we can do now is we can turn off our constraint, and I'm not printing out what epoch I'm on, so you can see it just restarted again from 1000. But what we want to do is turn off that data constraint and train this for a really, really long time. And I'll probably do that, and then maybe I'll upload those weights to the GitHub so that everybody else can have them too. But there we go, that's our model. Cool, so now we've built and trained our model for Word2vec and TensorFlow. If you're still following along, that's really awesome. I'm glad I didn't scare you away or bore you away. So next we can figure out what we want to do with these embeddings. If you've got any suggestions for the video or any comments on the video, please let me know. And other than that, I'll see you in the next video. Thanks for watching.